Good afternoon, students. Today we have a beautiful topic to discuss with. It's from metrology, right? So you have connecting rods here. Okay. How will you measure this inside diameter? What are all the ways we can measure this inside diameter? Vernier caliper, inside micrometer, then bore gauge. Okay. So bore gauge, bore dial, telescopic gauge, we have different instruments, and finally CMM. We cannot touch the component, we can keep it in a surface plate, and then we have a probe just to touch the points and then find the diameter of the ring. Okay. So these are the many ways we have measuring instruments. So let us look into one by one. We have three different categories. One is linear measuring instruments, another one is comparative measurements, that is, third one is precision measurements, right? So in linear measurements and angular measurements, we are going to measure inside diameter, outside diameter, length, angle, everything. Okay. So comparative measurements is we are not going to measure anything directly, but we are going to compare with the standards. So we have a standard diameter 10 mm. With that we can calculate how much it is deviated from the 10 mm length. Okay. So when these comparators are used, when you go for example, you are manufacturing this shaft, okay, in an industry. So this shaft per day you are going to measure this this diameter. For example, it is 30.05 plus or minus 0.05. So every time when you want to measure this, you have to take a vernier caliper and you have to have a formula. We have a very huge formula. Total scale reading equal to line scale reading plus vernier scale into least count. Okay, what is the least count of vernier caliper? 0.0. Micrometer, 0.01. Which is precise. Micrometer is precise. Okay. So it is not possible per day, per shift they are manufacturing some 800 components. How will you measure it well? Your hand will get swelled. Okay, you cannot go for that. So that we can go for a comparator, which is a mechanical comparator, where you can get the height of this particular thing, like diameter in the y-axis. So you can measure only the deviation. Take it, find it, put it in the comparator. Say how much it is deviated from 10. If it is plus or minus 0.05, this component is accepted. This component is rejected. What is the prime quality of making inspection? Either you have to accept the component or you have to reject the component. Right? So likewise, we have to take a particular component and see which instrument it has to be used. So in this we can use vernier caliper, bore dial, micrometer, inside micrometer, and telescopic gauge. The name, wherever you find the gauge, is not going to measure. It is going to tell only whether it is okay or not okay. So we have two things in the measurements. One is variables, another one is attributes. Variables are numbers. They are given numbers. Particularly, for example, your dimension is 25 mm. You can directly read numbers 25 mm, 24.98, so that the inspection sheet is full of numbers. In the counterpart, it is called as attribute. Whether you check this okay or not okay. That is attribute. Okay. So with that, we can take bore gauge, bore dial or bore gauge, and then we can calculate the diameter on the periphery of this at the top, at the middle, as well as at the bottom. Why we need to find the top, middle and bottom? So whenever you go for any measurements, you should always take average. What is the purpose of taking average? To maintain accuracy. Okay? So to maintain accuracy, you should take average of the same. Right? So whenever there is a slope or any problem with the machining, we can only find out by taking the average. So in today's scenario, we have several kind of instruments, sophisticated instruments has come. So one of the instrument is CMM, okay, coordinate measuring machine. So coordinate measuring machine, you can keep this in a surface plate, and you can take a probe, and if you touch that point, various points using the probe, okay, so you will get the total image or the total components 3D drawing in the monitor. So after going into the grid size image, you can just click with the cursor. From this point to this point, you can measure the center. Okay. The best way to use this connecting rod no-go is your pneumatic comparator. You will have a pressurized air inside this. So once if you dip into this, you will understand where there is a deviation. Okay. So this is how pneumatic comparator works, and this is how metrology is there for everything. So you can see a lot of engine components, lot of many components. Everything starts with design, then production, then quality control, then assembly, then customer. This is the way it goes. You understood what is metrology and how it is used. Thank you.
Thanks.